Density of states for the quantum well. The density of states is the number of different states at a particular energy level that electron are allowed to occupy. जो डेंसिटी ऑफ स्टेट है वो नंबर ऑफ डिफरेंट स्टेट हैं पर्टिकुलर एनर्जी लेवल के ऊपर जो इलेक्ट्रॉन्स हैं वो अलाउड होते हैं ऑक्यूपाई करने के लिए. दैट इज़ द नंबर ऑफ इलेक्ट्रॉन स्टेट्स पर यूनिट वॉल्यूम पर यूनिट एनर्जी. दैट इज़ द डेंसिटी डी इज इक्वल्स टू में curly d dash by में curly e. That is the number of states that represent the number of states per unit energy. It determines the density of states है वो determine करता है the general distribution of states as a function of the energy. Now in 2D structures such as quantum well, one of the k space component है is now fixed, and instead of finding number of k space enclosed in a sphere, we now consider a circular area with radius k. As in a sphere we have the three wave vectors kx, ky, kz, but quantum well is a 2D structure, so we have the two component of the wave vector, that is the kx square plus में ky square, and their resultant is k is equals to में square root of kx square plus में ky square. A symmetrical circular area is considered here. 2 डिग्री ऑफ फ्रीडम है वो एग्जिस्ट करते हैं विद इन द एक्स वाई प्लेन. 1 डायरेक्शन ऑफ कन्फाइनमेंट है वो हमने कंसीडर की है जेड डायरेक्शन. वी कैन कंसीडर एक्स वाई, बट इन दिस केस वी कंसीडर द कन्फाइनमेंट इन द जेड डायरेक्शन इज एक्सक्लूडेड. द एसोसिएटेड सर्कुलर एरिया इन के स्पेस इज गिवन एज द सर्कुलर एरिया area of circle is a is equals to में pi r square. So in this case ak is equals to में pi k square, and k is the radius of this circle, and this area is accompanied by the many states having different energy. A given state within this circle occupy an area given by a state is equals to में kx is kx multiply ky. That is when we extend this we get a kind of parallelogram rectangle, and the area of the rectangle is length into breadth, that is the kx multiply by में ky, where the value of the wave vector is 2 pi by lx, that is the per unit length. Kx is equals to 2 pi lx and ky is 2 pi ly, and the value of lx is equals to ly is na. Na is the number of unit cells along a given direction and represents interatomic spacing. Thus a state is 2 pi lx. Put the value of kx and ky, we get a state is equals to 2 pi lx into में 2 pi ly, that is 4 pi square lx into ly. The total number of state associated with the circular area n1 is equals to में ak, that is the जो circle का area upon में a state is equals to में when we divide it ak we have pi k square and a state is 4 pi square lx into ly. So we get n1 is equals to में k square lx ly upon में 4 pi. अगर if we include further spin degeneracy then this value is multiplied by 2. Spin degeneracy means the different electron or holes have the same spin. n2 is equals to में 2 n1, so 2k square upon में 4 pi lx into में ly, and n2 is equals to में यहाँ when we cut this then we get k square lx into ly by 2i. n2 है वो हमें total number of available state देगा for the carriers के लिए. Now including spin, now we define area density as d dash, and it is given as d dash is equals to n2 divided by lx ly. Put the value of n2 from above equation. D dash is equals to k square 2 pi square lx ly into lx into ly. lx ly से lx ly cancel, we get d dash is equals to k square by 2 pi, where k is equals to under the root 2m effective e by h cut square. As we know e is equals to p square by 2m mass effective mass is equals to h p square की value in the form of k square is h cut square k square, because p is equal to में h cut k, so p square is h cut square k square divided by 2 multiplied by effective mass, and the value of k square is 2 times of effective mass E by में h cut square. So d dash is 2 multiplied by effective mass E by h cut square into में 1 by 2 pi. D dash is equal to में m star E by में pi h cut square. Density of states is given as d dash E of the quantum well is curly d dash by curly E is equals to में m effective mass by में pi h cut square, and density of states of 2D is m star by में pi h cut square. ये जो इक्वेशन है वो रिप्रेजेंट करती है डेंसिटी ऑफ स्टेट्स को इन 2D विद द यूनिट नंबर पर यूनिट एनर्जी पर यूनिट एरिया, एंड इट इज़ अ कांस्टेंट क्वांटिटी बिकॉज वी हैव द d dash is equals to में pi m star pi h cut square, where the effective mass is constant, pi is constant, and h cut square is constant. Thus the value of density of state in xy plane associated with each value of kz. So it can be written as modified value of density of state is dE effective mass by h cut square summation he minus ekz, where he minus ekz is a Heaviside function step junction defined as he minus ekz 0 if e less than ekz and 1 if e greater than ekz. When we plot a graph between density of state and Heaviside function for a quantum well, we get this type of graph, that is the here it is value of 1, and below this the value of density of state is 0, and when we get the value of ek when we e is greater than ekz, we get the value ek, and after that it is constant. In 3D the graph of between density of state and energy is kind of this, that means the density of state is a function of the e raised to power 1 by 2, is varies as e raised to power 1 by 2, and for a quantum wire we have the density of state है वो vary करती है as a function of e raised to power minus 1 by 2, and for a quantum dot it varies as inverted parabola. As the size decreases from bulk to nanoscale, band gap increases and density of state decreases. that is जैसे ही size है वो 3D से 2D में गया, 2D से 1D में गया, या फिर 1D से 0D के अंदर गया, तो देयर बैंड गैप है वो इंक्रीज़ होता जा रहा है. जैसे यहाँ इतना है, यहाँ और भी बैंड गैप इंक्रीज़ हो रहा है. दैट मीन्स द डेंसिटी